me sharing in air quotes, fun thing that I ran into a little bit earlier this summer with Node.js. So hopefully coming out of this, you brighten your day by learning a little bit about Node.js's import mechanisms. Which is, yeah, totally useful to your day. So anyway, limited appeal. So we'll start with a puzzle. Here was a PR to the Fastify web framework from a while ago. And the title of the PR was support for named export in a specific version of Node.js. And that is the full functional part of the PR. The fastify.js is the main file that gets imported when you import Fastify. And the question for this talk is, what the hell is going on with this thing, and how can this possibly make a difference in Node.js? Because looking at that, what Fastify does is it has this Fastify function that it's exporting, and in one of the import mechanisms or the module systems in Node.js, that's how you say this is what the export is going to be. And then this Fastify thing has a couple of attributes, a self-referential Fastify and default. We don't really need to know why they have this kind of circular definition. If you define them here and then put on exports, then that wasn't good enough. But if you put Fastify, assign it to module.exports, and then assign those properties, that seems to work. So that's crazy. So we need some background for that. So using Fastify, and I'll try to, as I work through, introduce you to the Node.js code if you don't really know JavaScript. So here's how to use Fastify. You require it, and then you can use that Fastify function to create an app, and you add some routes, and then you start listening for HTTP server requests. So pretty straightforward. Or what you can do is you can get this required module and unpack it and just get the Fastify attribute off of that thing instead of the top level thing. Initially, at least in this case, that seems a little bit silly that you would bother doing that. It's just more work than this. And there's some added confusion with Fastify here, in that Fastify exports both the Fastify function as the top level export, but also as a property attribute of that top level export. And it's kind of historical baggage for why that's the case. But so yeah, as I said, that second Fastify example looks pointless. So why have these named imports at all? And a better example is when you have some large module name that you don't want to create a variable name for that module. So if you want to do that, and if you have some large open telemetry module name like that, and it exports like a dozen things, but you only want to use one of them, that's kind of the argument for doing this form of importing. So instead of some gross code, you get some nicer code. So, but so far I've just been talking about CommonJS, which is Node.js's original module system for doing imports, and that's where you're using the require statement to import things. But Node.js has a new shiny, not really shiny anymore, it's been around for a number of years, module system called ECMAScript modules, or ESM for short. And ES modules were developed over the period of about a decade for browsers mainly, so that browsers had a real module system instead of just a bunch of script tags, which all drop things in global variable names, which was insane for browser development. So the idea was to improve that system. In the interim, browser developers had developed other module systems to kind of bundle everything together and try to deal with that kind of thing. But the web world and the spec people wanted, something that was a spec part of the system. So that's why ESM came along. And one of Node.js's driving things is to stay compatible with the web, to be as close to JavaScript system browsers JavaScript standards as possible. So not supporting ESM was crazy talk. So there you go. Node.js is going to have two module systems at least for a long time, and compatibility is a difficult thing. So it's got to have both. And then as of April this year, when Node 14 went end of life, Node.js has major versions pretty quickly compared to other languages. All supported lines of Node.js fully support ESM. So we can just start using ESM everywhere, right? Not really. So it's a little bit complicated, and this talks about one of the complications. So to maybe help a little bit, I'll show a small example of a module showing CommonJS and then showing the ESM equivalent. So here I have just a little utility module, utils.js, that implements high and buy functions, which just print something to the console, and then they export it. And this is how you export in CommonJS, and this is how you require that high function and use it in CommonJS. In ESM, there are export and import keywords so that, well, we'll get to it later, what they are. And in Node.js, you can identify ESM modules with the MJS extension. There are other ways, but this is the way we're going to use here. So you see I have a utils.mjs this time, and a main.mjs that imports the utility and uses it. Looks pretty similar, not much difference going on. But there's a third case. A third case is NPM has this huge array of thousands and thousands of utility modules that people want to use that are all implemented in CommonJS, but users want to start writing ESM for their code. So now you have, you want to be able to import these CommonJS modules from ESM. This is not something that the V8 underpinnings of Chrome that Node is using will do automatically for you. So how do you handle this? So here I have main 3, which is an ESM module that's actually using some CommonJS code. So let's look about how that works. So let's go back to our Fastify example, which we're trying to work back to that PR and how it could possibly make a difference. In this case, I have an ESM module, and I'm going to use the ESM way of importing Fastify. And here I'm using a named import because that's going to be the bug that we're hitting. And then the same way to use it. So before that Fastify PR, if I tried to do this, this was the result. It would say syntax error, named export Fastify not found. And I'm cheating a little bit. It gave a little bit more explanation, this ... But in the real case where this came up in OpenTelemetry, and I'll show you later, most people don't read past the first 2 words in error messages. So you don't really think about that context when we start jumping to conclusions. And so we didn't actually get back to that until a little bit later in the discussion. So when we were talking about those cases before, the third case here, this is the third case because Fastify is implemented a CommonJS module because that's the way it always was before ESM came along. And actually for compatibility reasons, that way everyone can use it. Oh, and my selections are going weird here. Okay. So this is the third case. We have ESM code from users code using CommonJS code. And so let's go back to the PR. So here's the PR again, or the diff. And so in other words, we have, this is the case before. We have the Fastify function, and it adds some attributes to that function, then it exports it. And here's the case after. So how the hell could that possibly make a difference? Okay, I won't leave you in suspense because at this point I had no idea what was going on, and I started going back through the blog posts for every single release of Node.js, but at this point we're at Node 20, and the difference was actually Node 14.13. So I was reading through a lot of blogs, and the change logs are just a single message that shows the top commit thing and all the commits that we're going through. So anyway, to kind of explain a little bit more background, we'll talk about how ESM, the module system works. ES modules by spec are loaded in 3 phases. So the first phase is loading, and this is where you get an import statement, either in the browser or in Node.js code, and you asynchronously, that's important here, you go find either in the file system or in a browser by hitting the remote server and downloading, and you parse all the modules. And this is not executing the modules, this is just parsing them into a syntax tree. Separating this step from other steps allows browsers to, this is one of the fundamental design decisions, to be able to walk through all of the JavaScript code, find all of the imports, and be asynchronously downloading those, hitting the remote servers before having to execute anything. So you don't need to pause execution of JavaScript in the browser to be downloading all these things. Otherwise, it would be really slow. So the next step is linking all the import exports. We don't really need to talk about the details. And then the third step is where you actually evaluate the code. So back in Node.js Cowboy land, the way CommonJS module imports work, though, is you just do all of that synchronously in one step. When you hit a require statement, it's kind of like, at least my understanding, it's been a while, of a Python import statement. It's executing the Python code. When it hits an import statement, it is synchronously loading that module, parsing it, and executing that code, and then it's coming back to your code and doing work. So that's basically the way things work. The problem that Node.js is going to run into here is Node needs to deal with the differences, and we're trying to do compatibility between ESM code, which is has a certain import mechanism, and CommonJS code. So this is just repeating those three steps: loading, linking, and evaluating. The ESM spec intentionally doesn't define how the loading is done, and so that was intentional so that you could use ESM in different environments. So Node.js and browser. The way the browser downloads and finds code is totally different to how Node.js does it. Node.js is looking in package.json files and this node modules directory and loading stuff from the file system. The browser's hitting remote servers. And so the Node.js code has its own ESM loader, kind of two, depending on how you define it, and that's changing now. One that handles loading ESM code and one that handles loading CommonJS code. And the case that we're looking at is the second case. And so to support named exports, so that the loader step, so this is this first step, needs to know all the exported names from that module that you're importing before evaluating the code. So that means just looking at that code, just at the abstract syntax tree, you need to know what all of the exports are going to be out of that thing. So by design with ESM code, this is trivial. Those import and export statements are just nodes in the abstract syntax tree, and it is in an import statement, that string that defines the module that you're importing from has to be a raw string. It can't be a variable. So this is all trivial. Not so with CommonJS code. So require statements in Node.js is just executing and evaluating code. You can do anything. You can have variables in there. You can have these things inside if statements. You can be doing it repeatedly. So there's no absolute way to do this without actually evaluating the code. So Node has to do its best, which this was a bit of a gut punch when I realized this. I hadn't even really thought about it. You just kind of use all the modules in NPM and you're writing some ESM code. But as soon as you're importing CommonJS code, this is actually a does its best kind of job thing, which is not really something you frankly want in your import system in a language you're working with. So Node.js's best is they have this thing called the CJS module elixir, which is a thing that the Node core is using anytime you're attempting to do this loading step of a CommonJS module from ESM code. And so what that does is it does its best job. It has a bunch of patterns. There's a bit of heroic work in there. I think it's using WASM to speed it up so that's actually a fairly fast process. So it doesn't actually slow down imports at runtime. So yeah, this issue comment gives some details on percentages, and looking at the top 1,000 modules when he was going through them, it wasn't like in the 90s, it was like in the 80s or 60s. So there were a lot of modules where these named exports that are inferred, this best job that it can do, are not really exactly what they should be. So this is what Fastify hit. And this is the answer to the puzzle, is that, so here's this little function or file that I wrote that uses this CJS module elixir the same way Node is doing. And if we look at the before code, it doesn't find any exports. Re-exports is something different. That's about import star from something else. It's something we're not going to cover unless we do another lightning talk. And then the code after does find those two, and that's the difference. So yeah, a little bit of reason for why I got here. All of these, the Fastify example, the version that fixed this, and also the Node.js version that we're talking about, 14, were like a couple of years ago. So why did this come up now? So a little earlier this summer, there was the 1.15 release of the Hotel.js SDK. And then an issue came in and someone said this error. And here I'm showing a little bit more of the error message that actually came out for it. And it does actually explain it, but no one read this part for the first day of discussion on the Hotel issue tracker for this one. So the first conclusion that people jump to is this import in the middle thing that, oh, ESM's involved, and so it's one of the modules that's used for hooking into imports that is used by the APM agent. Is it that? No. Is it something about the TypeScript compilation? No. Is it because there's a fair amount of complexity going on here in OTel.js? And I'll just touch on a couple of them quickly. So the OTel.js code is written in TypeScript, which, if you're not familiar, I hope most people are familiar, is a language, a superset of JavaScript that adds typing to the language, and you don't actually execute that. You compile that down to some version of JavaScript, which gets run by whatever your JavaScript system is, your browser or Node.js or something else. And OTel, somewhat confusingly, has 3 different builds that it ships with. So every time you install an OpenTelemetry.js module from NPM, you get 3 different builds. One that's a CommonJS build. It's a pretty straightforward translation. One that's ESM code that one of the main authors of OTel.js actually thought was being used by Node.js code, but isn't. It's just there for some bundlers to use for browser side thing. And that's ESNext that I'm not sure anyone's actually using. So I'm not sure what the output of that is. We're not going to talk about the differences, just the CommonJS build that comes out of it. So trimming for brevity, in the specific example in this issue, this is a subset of the module that was hitting the error. So here's some TypeScript code, and that gets translated to this JavaScript code, which is the usual bread and butter of kind of the support that we're doing on JavaScript side. This is the kind of code that we're looking at, but people are quoting us this kind of code. And so it's pretty straightforward. What you're seeing here is TypeScript is dropping a utility function called export star that's going to deal with this kind of construct. And then it calls export star for each of those actual export stars in TypeScript parlance. And this is CommonJS code that goes. So for every one of these modules, TypeScript will emit this export star helper and possibly many other helper functions. So there's this create binding function that I didn't show as well, which can add a bit of code to the top of each of these modules. And it does a new version of that function for every single module because it wants those modules to be self-contained. So there are lots of files in OTel.js. They tend to have a nested structure, so they're re-exporting stuff from deeper files inside the packages. So you end up getting a fair amount of bloat in here, which impacts more the browser guys. Browser people are always super concerned about the size of their packages because they want the initial load to be fast and do that kind of thing. So OTel, in that version that broke, attempted to use this utility that TypeScript allows, because this is something that's submitted by Microsoft as well. You can use this thing called tslib, and what it does is TypeScript, if you tell it with a compilation flag, will, instead of emitting all these utility functions, will just use one in tslib. So instead of this, every module will just be importing this tslib and using the utility function in tslib instead. So you get one of those defined, and if you have 1,000 files, it's still using that one version of that function, and so you can get smaller bundles doing everything. Except, do you notice that instead of just calling export star or tslib export star, we're doing this wonderful little thing. And so what the hell's going on there? So if you call export star function in Node.js, there's the this parameter inside that function execution. In this case, it's just a function that's not bound to anything. So this will be the global object, which is fine, which is what the thing expects. But if you call tslib.export star, the this parameter inside that function execution will be the tslib module, which is changing how it's executed. So you don't want to do that when you're wrapping things. So you use this little trick that is just sequencing so that this thing is actually now still the global object. So it doesn't change how that thing's executed. But the return value from this thing is that function. So we're still going to execute that function. So this is a little cheat technique called indirect calls. The TypeScript added in 4.4, except the wonderful thing is that that technique breaks Node.js, a CJS module lexer, so you're screwed. And as it stands right now, OTel.js just backed out the attempt to use tslib, and they're figuring out what to do next. So that was the whole bug. It was walking through kind of little subtle things, a bunch of little subtleties, and opened my eyes a little bit on the compatibility between the two module systems in Node.js and how to deal with that.